Okay, so this is a tutorial on division, and what we're doing is finding the quotient. Let's start with two numbers then. 72, let's say, nice straightforward number, very useful for all sorts of things. 72 divided by 3, so just keep it pretty simple to start with. So the first thing I want to say is, what have we got here? We've got, well, the thing that we're trying to find we call the quotient, and these two numbers here that we're working with, the number that we're that's going to do the work of dividing, we're going to call that the divisor. So nice and straightforward, the divisor is the number that is doing the divide that we're dividing by. Okay, so this one's going to be doing all the work. The thing that it's going to be working on is this thing here, and it's got a very similar name. We just call it the dividend. Okay? Right, let's get to work on it. So 72 divided by 3, and the first thing I want to do is, rather than setting it out like this, is I'm going to experiment now with changing the symbols. So 72 /3 is exactly the same as this, but it uses, I suppose, a more up-to-date symbol, the / that we see on calculators and computers. And this gives us a clue that it might be better to actually turn the fraction bar all the way around and do it vertically, 72 divided by 3. So we set it out like this. Alright, let's just go ahead and calculate now. 3 into 7, or 7 divided by 3, is how we're going to start. We're going left to right because this is division. If we were going to multiply, we would go right to left. But division is the inverse of multiplication, so we start with the larger numbers, in this case the tens. So 7 divided by 3 is actually, of course, 70 divided by 3. But we need to get either exactly in there, or, well, it's going to be a little bit under this 72. So we're looking at what multiplied by 3 is going to give us 70 or under. We're trying to get as close as we can. And the answer is 2, because 2 times 3 gives us 6, but if we're working in the tens column, that would be 60. If it was 3, well, then it would take us way over. That would be 90. So we're going to stick with the 2. 2 times 3 is 6, so that's 60 when it's in the tens column, and that gives us 1 left over, which we carry across. So our 10 here is added to our 2, giving us 12. 12 divided by 3 gives us 4. So 12 in 3 equal parts gives us 4. So we've got 24. Okay, pretty straightforward when we've got simple numbers to deal with. Now let's try something a little trickier. Let's try 91 divided by 13. Alright, so now we could keep this like this, and we could try operating in this format, but I think most of us would find it easier to do it this way. So we're going to use a kind of bit of scaffolding here to structure our division. So 91 under this, that people sometimes call the bus stop. It's not a symbol, by the way, because if it were, we would read it as 13 divided by 91, which wouldn't be the same at all. We don't want to divide 13 into 91 equal parts. We want to divide 91 in 13 parts. So I suppose a downside to this is that we run the risk of forgetting what it is we're doing exactly. But this, we should remember, is the dividend, and this is the divisor, the thing that's doing the work of dividing. Alright, let's just go ahead then and use it. So we've got 13 into 91. We can't do 13 into 9 for the same reason as up here. So we've got to use the whole number here, 13 into 91. Well, that means we haven't really got an easy method of doing this, and so we've got to think about this in chunks. Now, chunking also called the partial quotients method is when we really guess what the number would be and then see if that gets us close to what we've got, and then do another chunk and another chunk until we get up to 91. So we're going to start with 13 times 10. 13 times 10. Because that's a nice friendly number, easy to calculate, we've got 130. So the partial quotients method works like this. We start with something, we realize that's not going to work. If we halve it, we're going to have 13 times 5. So if we can halve this number, we know that's 65. So 65 is the number we're going to work with because we know that 5 times 13 is 65. That's the number that we want to start with. We could have started with something else, but we can start with a nice substantial chunk. So what we do is we write down that we've multiplied by 5, and then we use subtraction. Because what we want to know is what we've got left over, and then we want to have a go at that as well. So we've got 65 from 91. Well, if we've got subtraction, we should remember that whatever we do to this number, we do the same to this number. So if we take this, let's say, down to 90, and this one then down to 64, then that makes it much easier to calculate 26. And if you prefer to use the standard method of crossing this out and borrowing, then fine. But doing a mental calculation is pretty straightforward. We can add back to be sure, so our mental check is very important. 65 add 26 gives us 91. Okay, so we've got down to this chunk here, and the next step is to do something again very easy. 13 just multiplied by 1. So in other words, we're just going to work with 13 now. So we take another chunk off, 13. So this is repeated subtraction really. And if we take 13 off 26, that's very easy to do. We get 13. And we need to remember to write down that we just did 1. We just took 1 13 off, so times 1. Now we're nearly there. We've got to do another chunk of 13 times 1. Okay, so that means we take off another 13 and we end up with nothing left. We write down times 1 again, and we add up all of these to get the number of times that we actually multiplied by to get to 91, which is 7. So we write 7 at the top here. So 13 times 7 is 91, or 7 times 13 is 91, because we can commute with multiplication. And this is the partial quotients method, or chunking. Alright, a fairly cumbersome method. Another way of doing it is long division. So we're going to try long division now using slightly different numbers, I think. Let's use 7, and here's our bar again. 168. So again, 168 is our dividend. This is the divisor. So when we're reading this out, we must remember to say 168 divided by 7. We read right to left. So this is not a symbol. It's not 7 divided by 168. Anyway, when we're sure about what we've got here, we can go ahead and use the method. So we're going to start with these two figures here, which are 160, because if we had something like, if we had 7 here, or 8 or 9, then we would just work with the hundreds. But because it's a lower number than the number we've got here, we take these two together and say we're going to start dividing into this. Now the advantage of this method is that when we think about it as just 16, 16 divided by 7 is 2. and a remainder. In other words, there are only 2 7s in 16, and 2 7s are 14. So we multiply these back. You're never going to get a very big number here, and so it's always going to be a nice simple number up here. Whereas with the chunking method, remember we had to think about 13 into 91. That's quite a difficult thing to get our heads around. Here, it's a lot easier. We've just got 2. All right. Now we use subtraction just as before to find out what we've got left. And 16, which is actually 160, but we think of it as 16, subtract 14 gives us 2. And we must remember to add our 8 because it's actually 168 that we're subtracting from or dividing into. All right, so 28 divided by 7 now is the next step of our problem. And actually, if we know our times tables, 28 divided by 7, we've got an answer because that's 4. So we've got an exact division here. 4 times 7 gives us 28. Write it down underneath just as before, subtract it so we can see that we've definitely got nothing left over, and we get the answer 0. So that's the long division method. In this case it didn't involve any borrowing, which was the sort of thing going on here. It wasn't too complicated, but obviously these will get much more difficult as we use larger numbers or have more awkward arrangements. Okay. Now, one final thing that I want to look at is how to make life simpler for ourselves. So let's just think of it in a slightly different way. We use the same numbers, I think, here so that we don't have to get used to another set of numbers. So let's take the 168. Let's just write it here. Let's take the 168 and write the 24 underneath. So we've got now 168 not divided by 7, but this time divided in 24 equal parts, which will give us the answer 7. But if we didn't know the answer, if we didn't know what the quotient was, how would we make this simpler? Well, again, we've got this idea that we could do something to the top and the bottom, both sides of the dividing line, division symbol. And what we want to do is bring these numbers down. So let's think about bringing this down. I don't know. We could think about halving it to start with. So if we halve this number, we'd get 84. What do we do to the bottom? Well, it's just like subtraction, really, in that whatever we do to this side of the division symbol, we also do to this side. So it comes down as well. So we divided this by 2, we've got to divide this by 2 as well. So we can rewrite this to make life easier for ourselves as 84 divided by 12. And in fact we can do that again. So what we were doing first, we could have divided it by 4 straight away. We'll divide it by 2 again, and we've now got 84 becomes 42. There we go. 42 divided by 6. And we could keep rewriting this again and again until we don't have to halve and half. We could really, have divided by 8 straight away. It looks. Let's just see. So 21 now we've got? Yeah, 21, and we halve that as well. We've got 3. So yeah, there's lots of things we can do. And in fact, we're nearly at an answer there. But I think you can see that just by halving it and halving it and halving it, we've made life a lot easier for ourselves. We've now just got 21 divided by 3, which is 7. 7 times 3, or 3 times 7, gives us 21. So don't forget this strategy of rewriting numbers if we want to make them easier to calculate. Okay, I hope that's helpful. And in the second part of the video, what we'll do is look at some of the ideas that are behind some of the theory that's behind these methods that we've been using, and also just discuss how we can fiddle around with it a little bit more. Okay, let's look at this example then of 168 divided by 24. So 168 divided by 24, and we decided to simplify it. How did that work? Why did that work out? So simplifying what is a fraction here is a very, very useful strategy, and we said that we were able to bring this down and bring this down as well. Let's see this operating in a stack here. I'm going to just let's just change this to dividing it not by 2 this time, halving and halving. Let's do something a bit more complicated, really. Let's say I could look at this 168 and divide it by 3. So I just happen to know that 168 divided by 3 is 56, and I'm very confident about that. So I try to bring that down by dividing it into thirds. So we've got 56 here at the top, and now the divisor divided by 3 is going to be 8. So what have I actually done here, and why does this work? Well, what I'm doing is reducing that 168 to a much, much smaller number without changing the quotient that I want to find. Now in this case we start with 24, so that's this end here. So there's our 24, and we're going to reduce that to 8. So this 24 here is going to come down to 8 here. The 24, let's just put that there, comes down to 8. But the other dimension is where I've got my answer. So here, let's do it underneath here, is my quotient of 7. And when we bring this stack down in just a moment, I want you to see how this quotient doesn't change. So okay, let's bring the total of number of cubes here down to 56, and you can see this has changed. This has gone down as well, so the total's gone down and this has gone down as well, but the quotient, the thing we're trying to find, that hasn't changed at all, and that's why we can happily do this. If we want to work with large numbers, then we can. There's no problem with that, but obviously the smaller we can make that stack of numbers, the easier our calculation is going to be. Alright, so there's some good news. Some more good news over here. This time we've got a trickier thing. We can't simplify it, so we've got 91 as our quotient, as our dividend. So the number we want to find, our quotient, is going to be, 7 again. So here's 7. So that's what we're trying to find. Okay, so that's our answer. On the left here we've got 13. Let's just check. Yeah, 13. So we're saying that the missing number, if you like, the quotient is 7, but the divisor is 13. We can't, though, make this simpler to get at this result of 7. All right, there's nothing that we can divide these into to reduce the number, so we're just stuck with 13 into 91. What are we going to do? Well, one thing we might think we can do is split the 13 up into 10 and 3 so that it becomes 91 divided by 10 and 3. And would that make life simpler? Well, no. But let's just see why it wouldn't and why we can't really proceed from there. What we're saying, what we're trying to do here is we're trying to divide the 91 into 10 equal parts and then 3 equal parts, or the other way around. So let's have a look at that. If we've got 3 here, and this is our 10 here, what would happen if we took that 3 and said, well, let's divide the 91 into thirds? Well, we'd have to take, we'd have to divide it equally, so we'd have to, let's see, we'd have to go along here. So that's 1/3 divided off. And if we go from the bottom, there's another third of 91. And I don't know what the total number here is, but it'd be difficult to calculate because we've actually got fractions, we've got parts of whole numbers here, and that's going to be very difficult to work with. If we did divide it into 10 equal parts to start with, that would be equally difficult. So it's not something we can do. It's certainly not something we want to do, but it's not something we can do anyway. Because what we're actually being asked to do, what the problem is divide 91 into 13 different parts. And it doesn't matter that 13 is 10 plus 3. We're still stuck with this thing of dividing it into 13. So let's just erase what we've done here. We don't want to do that. And we don't want to divide this up. Okay, so what we do want to do, what we've actually got, is 13 rows here. Okay. And what we want to end up with is just the answer 7, which would be 1 row of 7. So it would go down like this. Now this gives us another interesting result that we ought to think about, which is that yes, this is 7 down here, so it's a row of 7. If it was knitting, it would be 7 stitches. Here we've got 7 buttons or squares. But what we've also got is 1 row. Okay, so part of this 13 is a 1 times 13 in fact. So we've got 1 row of 7, so it's 1 times 7. And what we're saying here is something very useful, that 1 is the identity for multiplication and division. Well, let's just keep this simple. Let's just write when we're timesing and dividing, if you like, for multiplication and division. Now this is the same as saying for addition and subtraction, the identity is 0. So 0 is the identity for addition and subtraction. What does that mean? Well, any number A, let's call it A, add a 0, as you well know, you end up still with A. So if it was 4, add 0, you've still got 4. Nothing changes. It's the same here. If we've got 4 again, we'll represent it by A, any number. If we multiply now, or divide by 1, it stays the same. It's still A. Now this is a very interesting idea because it gives us a way of thinking about how to make life even easier for ourselves by changing a division into a multiplication. I'll show you what I mean. Let's say, for example, we had coming up in a problem 42 divided by 7 divided by 2. It looks like a difficult thing. We might wonder which we should do, what order we should do it in, and we ought to know that with division we can't simply commute because, as we said before, 42 divided by 7, for example, isn't the same as 7 divided by 42. If we want to do things like that, if we want to start commuting and associating, we can change this into a multiplication, and we can do it this way. We know that to divide by something is to multiply by 1 divided by that number. 1 divided by 7 then. And so we can change this one as well to 1 divided by 2, in other words a half. So this time we've made life a bit easier for ourselves by changing the operation to a multiplication. The identity here isn't going to change anything at all. So 1 times 42 is simply 42. And in fact, we could rewrite that 42 divided by 7, which is what we had originally. Okay? Times 1 divided by 2. We might, though, want to change this around. And I suggest that would be easier than thinking about it in this way. So I'm going to rewrite this 42 times 1/2 times 1 divided by 7. And that gives us the much easier calculation of 42 divided by 2 times 1 over 7. 42 divided by 2, we're just halving it in other words, gives us, well, 42 in half gives us 21. And 21 times 7th is the same as saying 21 divided by 7. So we've kind of gone into multiplication so that we can move things around. We did a bit of commuting here. And taken it back into division at the end and ended up with something much simpler than we had before. So 21 divided by 7 gives us the result of 3. Okay, well, I hope you followed that. I hope it made sense, and I hope the examples here gave you a clearer idea about what we're actually doing when we're dividing one number by another.